So hi everyone, how you guys doing? So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And at this particular channel of Unacademy, all the concepts of physics, chemistry, and maths are being taught to you completely in English. So that students who are not very comfortable with Hindi also have a way to learn without any inhibitions. Okay, so the topic that we are discussing right now is waves. This is a series that I host for class 12 students. This is a quick review series where we are going over some key concepts of all the class 11 topics very quickly in order to help class 11 students looking to take JEE in the next month help these topics revise very quickly. All right, so before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the IIT JEE exams, both mains and advanced. Now all this 7 years, I've been teaching in offline setups. And then from last year, I started teaching in the offline or online setups. Now, as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. So just like IIT JEE happens in two stages right now for you guys, back when I took JEE also, then also it used to happen in two stages. Okay, so this is called screening and mains. So in the screening paper, which was an objective paper, I secured an All India rank of 192, and in the mains paper, which was then a subjective paper, I had secured an All India rank of 447. Now, as a student, I also qualified the NTC Stage 2 examination and I was also in the top 1% in the NSCP. Now, as I said, I have coached many students to top ranks in my years of offline classes. Now, I hope to continue guiding you guys to your dream colleges and dream ranks through this online mode. Okay. So again, for students who are worried about how their studies are going to go ahead in this time where most of the students hardly have any access to good education and their educators. So you guys have this wonderful opportunity where you can get the Unacademy subscription. This subscription brings you benefits like live classes where you get to interact with your educators on a regular basis. Now these classrooms also have live polls and leaderboards, and of course you have regular test analysis sessions and a test, so which is very important for an exam as competitive as JEE in nature. And of course in all the Unacademy Plus courses you have another feature which is live doubt clearing sessions. So for all Unacademy Plus courses, every fourth session is supposed to be a live doubt clearing session. So after every three teaching sessions you get one session completely dedicated to your doubt solving. Okay, now along with all these benefits, of course, you also get the chance to study from the topmost educators from all across the nation from the comfort and safety of your home. So I think that's a huge opportunity. That's a wonderful opportunity that all the students now have, and I think you should all try and capitalize on this. Okay. Next, so how do you avail these benefits and how do you get the chance to get the best education possible in this time? So there's one great way. Again, you need to install the Unacademy app. That's the first step. So you will realize the moment you install the Unacademy app, you will unlock for yourself free features of the Unacademy, like free courses. So there are a lot of free courses running on the Unacademy app, which you can join just for free, just after installing the Unacademy app. Plus, there are special classes happening on the Unacademy, which are again free for all students. Okay, so any student who has just installed the app can attend these special classes. Then, of course, you have quizzes. So this is like the one that we keep having every Tuesday. Okay, so you can take part in these quizzes also just after installing the Unacademy app. So for all these free features, you will realize no subscription is needed. Okay, all you need to do is install the app and put the code RD live to unlock all these free features. Okay, now once you do that, once you unlock the free features, this will give you a flavor of how your preparation is going to go ahead with your Unacademy platform. So if you like what you see, then and you finally decide to get yourself the Plus subscription, these are the steps that you need to follow. So you can go to the Plus section of your Unacademy app, select your goal as IIT and click on that Get Subscription button. The moment you do that, you will be redirected to the payment page wherein you can enter this code. So you will find a box which will say, do you have a code? That is where you can enter this code RD Live. So this will give you a 10% off on all your subscription fees. Okay, be it for your Plus subscription or be it for your Iconic subscription. So as I said, now you can choose from two kinds of subscriptions. The fees of these subscriptions have been mentioned here. Now you can, based on your study needs, you can choose one subscription. And when you click on proceed to pay, you can also now choose from a lot of no cost EMI options, wherein you can break these payments into small parts so as to reduce the burden. So go for a subscription that suits your needs, and do not forget to use the code RDLive. Next, for those of you who don't know what the Iconic subscription is, let's tell you about that quickly. Okay, so the Iconic subscription is a new offering by the Unacademy, and this will take your IIT JEE preparation to the next level. Okay. All right. So with this Iconic subscription, you are allotted personal coaches from our team of experts. So these personal coaches will guide you and mentor you throughout your IIT JEE journey. And of course, you also get to attend a lot of IIT JEE workshops, receive expert guidelines from time to time, get study planner and regular test analysis sessions. So you are getting all these benefits apart from your plus benefits already that you have. So if you are a student who needs more personal attention for their preparation, then you should go for this subscription. Okay. Next, for all these students who have just entered class 11 and are worried about how to go about their studies for the next 2 years, now there is nothing to worry about, because Unacademy is now bringing you the combo subscription, which takes care of all your study needs, be it your class 11 CBSE studies, be it your class 12 CBSE studies and hence boards, and be it your be it your IIT JEE Mains, be it your IIT JEE Advanced. So all those study needs will be taken care of with the help of these subscriptions. So there are four combo subscriptions that Unacademy offers you. The first combo brings you the Iconic subscription for IIT JEE and the Plus subscription for CBSE 11th and 12th. This subscription starts at around 4,600 a month. The second combo offers you the Iconic subscription for IIT JEE and Iconic for CBSE 11th and 12th, and this combo starts at 5,500 a month. Finally, you have a combo which offers you the Plus subscription for all three, Plus for IIT JEE and Plus for your CBSE 11th and 12th. This combo starts at around 3,000 a month. And you have another combo wherein you get the Plus subscription for IIT JEE and the Iconic subscription for CBSE 11th and 12th. And this combo starts at 3,900 a month. So depending on where you think you need to focus more and what are your specific study needs, you can choose from any of the combo that suits your study needs and then leave all the worries behind. So let's say hello to all these guys. So hi Rajesh, hello AP, hello Motilal, hi Amod Kumar, hello Raj. How are you guys doing? All right, so this is a list of upcoming tests in January, and you guys must not miss out on these. So the Unacademy Combat is happening on the 31st of Jan now, and you have AIM Advanced IAT 2021 exams happening every Saturday. Very, very important for all students aiming for the Advanced 2021. And then you have unique DPP discussions, which are happening every Monday through Thursday. So make sure you're not missing out on these wonderful, wonderful features. Now, the students who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. So a lot of times, a lot of students give me the feedback that they have subscribed to the channel Unacademy JEE English, and they have clicked on the bell icon. They still do not receive timely notifications. So there is this solution for you. You can join this Telegram group, and that will make sure that you're not missing out on any of the lectures and sessions happening on this channel. You will always get timely notifications for all the sessions happening here. Next, so finally, let's get started with today's quick review. Okay. So good evening, Mahi. How are you? All right. So today we'll be talking about standing waves. So far in our discussion of waves, we talked about the introduction of waves, where we talked about the basic wave equations, and we talked about interference phenomena in the last class. We said that four phenomena basically result from superposition of waves. So those were interference, standing waves, beats, and okay, so these are the three phenomena that result usually from superposition. Okay, so now today we are going to talk about standing waves. So this is what a typical standing wave looks like. So you can see in the image here. So you have two waves. One is traveling here. So the blue wave, you can realize, is traveling towards right. It is carrying energy towards right. The red wave, on the other hand, is taking energy towards left. So these are two equal waves which are traveling in the opposite direction. So when these superimpose, then they form the final black thing, which is the result of this superposition. Okay, this is what you call a standing wave. Okay, so every standing wave you will realize has these points. So you will notice here that there are these points which are never moving. Okay, so you can see in this diagram these points are called nodes, and then you have points which are oscillating with high amplitudes. Okay, these are called antinodes. So every standing wave is characterized by nodes and antinodes. So let's get started with our discussion of these. Okay. So first we'll talk about the reflection of a wave from a rigid wall. So if you have a wave which is incident and moving in let's say a medium, for example, taken as the string here. So if a wave is traveling here and it encounters a rigid boundary. So what is a rigid boundary? A rigid boundary is something which does not move. Okay, so this end is never going to move. It is fixed. Okay, so this is called a rigid boundary or a fixed boundary. Okay, so when a wave is reflected from a fixed end, then the reflected wave gets inverted with respect to the original wave. So if you have such a wave which is incident, you realize the amplitude, the disturbance was up towards upside. Then the reflected wave is inverted. Okay, it has disturbance traveling towards the downside in the opposite direction. So that is the effect of reflection from a rigid boundary. Again, we are not going into how this happens because this is a review class. So I'm just quickly telling you this, not explaining you that in detail. I'll explain it in case you want to know in this lecture when I take it up for class 11 students. Okay, so when a wave is reflected from a fixed end, the reflected wave gets inverted with respect to the original wave. So therefore, if the equation of the incident wave can be written as y incident equals a sine omega t minus kx. So this is a wave which is traveling in the positive x direction. Then the reflected wave equation becomes reflected is minus times a sine kx minus plus omega t, or I can say y reflected is a sine omega t plus kx plus pi. Okay, so it not only changes its direction but also gets a phase change of pi. Okay, so that is what happens in reflection through a rigid boundary. Then you may have a reflection through a free end. Okay, so here you realize there is a rod, and in the rod there is a bead, and the string is attached to this bead. Now this end is free to move. So this is called a free end. So whenever reflection happens through this free end, okay, then the reflected wave travels without inversion. Okay, now if the incident wave equation is like this, then the reflected wave equation simply becomes this. Okay, so there is no phase change in such a reflection. Again, I'm not explaining that right now. We are just quickly talking about what happens. Okay. Now, what happens is that a stationary wave or a standing wave is the superimposition of two equal waves traveling in the opposite direction. And this results in a standing wave. So imagine what is happening is, you know what a wave does. Wave is propagating a disturbance in this direction and carrying energy and momentum in this direction. Okay, so carrying energy essentially in this direction. So if you have another wave which is traveling equal wave, which is traveling in the opposite direction. So these two waves, what they are doing is this is one is getting energy in this direction, this one is getting energy in this direction. And if the waves are equal and traveling the same speed, same amplitude, same frequency, then you realize the amount of energy getting transferred by one wave is equal to the energy getting transferred by the another wave. So since these two are moving in the opposite direction, so you see no net transfer of energy. So what you say is that the energy gets trapped within that region in which you have these two waves traveling in the opposite directions, and that is what forms a standing wave. Okay, so as I said, the wave propagating in a medium. Whenever how do you achieve two equal waves traveling in opposite directions? It is usually done by reflection. Okay, so when a wave traveling in a medium gets reflected at a boundary, it produces a wave of the same kind just traveling in the opposite direction. Now, the superimposition of these two waves will always give rise to something that we call standing wave or a stationary wave. The formation of standing wave is practically seen only in bounded medium. So please note, you have to have a bounded medium. Okay. In open mediums, obviously, you realize the medium are extended up to infinity. So there will be superimposition for a bit and then it will stop, right? So in a bounded medium, however, the two waves one getting imagine this is the boundaries. Okay, one wave is traveling, it gets reflected from here, and hence keeps getting reflected from the two boundaries and keeps traveling like this. Similarly, the second wave is traveling in the opposite direction, it also gets reflected from these boundaries. What happens is that these two waves keep on traveling between these two boundaries, keep on getting reflected from the boundaries, and they form a stationary wave in the bounded region. Okay. Next, so as a result of this superimposition, different points of at different locations of the medium start oscillating with different amplitudes. So that is the result of superimposition. I told you superposition, what that causes is that every harmonic wave is trying to create a SHM. Now, this wave is trying to create some SHMs for medium particles. This wave is also trying to create some SHM for medium particles. The resulting SHM would be the result of the superposition. So, as a result of superposition, the amplitudes of SHM at different positions would become different. Now, there will be a points wherein the two waves will superimpose in phase, and at these points will be called antinodes, and here the amplitude will be 2a. So you should remember this whenever you have two waves traveling in the opposite, traveling in any direction for that matter. If they superimpose in phase, so there are two SHMs happening in phase, so the resultant amplitude is double. Okay, similarly, you may have other points where the two waves superimpose out of phase, so they cancel each other out, and such points are called nodes. So that is what you can see here. Okay, so take a look at this. So I'd shown you this earlier also. So these are two waves traveling in opposite directions, and the resultant superimposition is creating nodes and antinodes. Nodes are the points which become fixed, which never move, and antinodes are the point which start moving with a 2a amplitude. Okay, so this is what a standing wave looks like. Now you realize because of these nodes, what happens is that there cannot be any energy that is crossing from here to here. Okay, no energy is traveling from here to here because this point never lets any energy pass. This is a stationary point. Okay, so what happens is you call these loops. So this is one loop, this region is one loop, this region is another loop. So you have formation of loops, and the energy of any loop gets trapped inside that loop only. Okay, so that is the result of superposition that you will see. There will be no net transfer of energy. Energy would be, in fact, stuck in loops. Okay. All right. So let's move forward with our discussion. So again, if you wanted to talk about the distance between two successive nodes and antinodes, then there would be half the wavelength of lambda by 2, where lambda is the wavelength of either of the superimposing waves. Okay, again, yeah. So here you have the equations also. So from the equation you will see that. Okay, then you have a distance between a node and the adjacent antinode is lambda by 4. So you can see this characterizes a complete lambda, complete wavelength. So this distance is lambda, okay, which will be the wavelength of the either of these superimposing waves. Since these are two equal waves, so they have the same lambda, same frequency. Okay, so you realize the distance between one node and another node. This is lambda by 2, which is half that wavelength. Similarly, the distance between the two consecutive antinodes is also lambda by 2, and the distance between a node and an antinode, okay, this distance is lambda by 4. So you should remember this. This will be using a lot in our problem solving. Okay. So all points lying between two successive nodes now are always in the same phase. Now this is interesting. Now in case of traveling waves, you realize every particle one next to another is oscillating with slight phase difference. Okay, so you realize that there is a slight phase difference between any two consecutive particles. Okay, and you realize here what happens is that this entire loop, this part will be oscillating in the same phase. So you can see from here also, if you notice all these guys, they are reaching their extremes at the same time. Okay, then they are reaching their means at the same time. Okay, and reaching all their other extremes at the same time. So all these points are always vibrating in the same phase. So that is a characteristic of a loop. All the points of a single loop always oscillate in the same phase, unlike a traveling wave. In traveling wave, no consecutive particles can have a same phase. So same phase starts repeating itself after a length of lambda. Okay, but here, all the points which are in one loop are always in the same phase. Also, they are all out of phase with the particles lying in the between the adjacent pair of nodes. So you can notice these guys will oscillate in one phase, and the phase difference between the oscillations of these particles and these particles would be pi. Okay, you can see that once these guys are reaching one extreme, these guys are reaching the other extreme, and so forth. So again, you can see from here also. So when this guy reaches here, the other guy reaches here, and same here on the opposite side also. So these two particles in the two consecutive loops always oscillate in opposite phases. Okay. So remember all of these things. It's just a quick revision. Okay. Now we want to mathematically find the equation of a standing wave. So for a standing wave to be formed, you know that it has to be reflection from a boundary. Okay. So we will take up two cases. Okay, one where you have reflections from a free end and one where you have reflections from a rigid end. So imagine this was the wave, incident wave. Okay, and this was the reflected wave. So they are traveling in this kind of a bound medium, let's say here between two strings or something like that. So because this is a free end reflection, so okay, so this is a different kind of superposition which you see in organ pipes usually. Okay, so if suppose the reflection is happening from free end, so incident wave equation will look like this, and the reflected wave equation will look like this. Now, if you find the superimposition of these, y, the resultant wave equation would be y1 plus y2, right? And what you can do is apply the formula of sine a plus b equals to sine a plus b by 2 into cos a minus b by 2. You get this equation. Now, what you realize from here is that the amplitude of every point is dependent on its position. So this term is telling you the amplitude of any point at any location. Okay, all right. And so you realize all the points are now performing SHM because this is the equation of SHM with different amplitudes. Okay. Now remember, in traveling waves, all the points perform SHM, all the medium parts perform SHM with exactly the same amplitude. Okay, but with different phases. Here you realize the phase is going to be exactly the same for all the particles. However, their amplitudes of oscillations are dependent, are a function of their positions. Okay, in a traveling wave, the phase was a function of position and the amplitude was fixed as A. Here you realize the amplitude depends on the position and the phase is fixed. Similarly, if you add two standing waves formed by reflection from a rigid end, then the equation of the incident wave would have been like this, the equation of the reflected wave would have been like this, and you would have gotten this kind of a resultant equation. Again, you will realize that both these equations, please note, both these equations, this one or this one, both will follow or will obey the general differential equation of a wave. Okay, so let's make a note. Note both the equations shown below obey the differential equation del 2y by del t2 equals c square times del 2y by del x2. Now you can check that for yourself and you will realize both these equations are actually obeying this differential equation. That is why this is a wave. That is why we are calling this a wave. Okay, this is a wave, though this is a standing wave. It is different from your traveling waves. You realize when we talked about traveling wave, we said traveling wave has or does obey this differential equation. It is one class of solutions, but that was not the only class of solutions of this differential equation. Turns out this is another class of solutions of such a differential equation. And obviously, this is also representing a bounded function. So if you remember, we had discussed that whenever any wave obeys this differential equation and represents a bounded function, it is a wave equation. Okay. All right, no one cares. So why don't we have a practice problem? So you have been told in a stationary wave, the phase difference can not be pi by 3. Is this statement or true or false? Is the statement true or false? Phase difference between any two particles cannot be pi by 3 in a standing wave. True or false? Starting with a very, very simple conceptual question. So let me know your answers, guys. Okay. Hurry up. This is a very, very easy one. Just give me a quick true or false. Okay, that is strange. Well, this is a very, very easy one. Come on. Just answer true or false. I just told you about the phase differences. So if you have just heard me also, then also you should be able to answer this. I told you, right? What about the phases of every particle which is contained in a single loop? They all oscillate in the same phase. And how about the particles which are oscillating in adjacent loops? They always have a phase difference of pi, right? So yes, that statement is true. No two particles can have a phase difference of pi by 3. That is not possible in a standing wave. Okay, you guys should really pay some attention to what I say. Yeah, I don't know. I don't know what you guys. Anyhow. So let's move on to the next question. Now, this one, please practice on your own and try and give me some answers. You've been told that the displacement of a standing wave on a string is given by y equals zero point 0.4 sine x sine 0.5x into cos of 30t, where x and y are in centimeters, and you have to find the frequency, the amplitude, and the speed of the component waves. This is a standing wave which must have been formed by two waves which superimposed. And what is the velocity of the particle at x equals 2.4 at t equals zero point 0.8? So what are the component waves that would have formed this standing wave? So I'll give you a hint. Remember here, remember this. So if you have the cos in kx, then you have these kind of equations. If you have sine in kx, then you have these kind of equations, right? And from these, from the equation of the standing wave, you can find the value of k and omega. Once you have the values of k and omega, you can find the component wave equations also. Okay, so use this fact and try and tell me the component wave equations. Okay, so what do you think? So you know k, you know a, and this is 2a. This is 2a. Again, go through this equation. This is 2a. Okay. So from here, what can I say from the given equation? Okay, so let me only answer. From given data, what I realize is 2a equals 0.4, therefore a is 0.2. Okay, and what is omega? Omega is 30. What is k? K is 0.5. Therefore, the equation of component waves, component wave equations will be, so you have sine in kx. Okay, when you have sine in kx, then you have one equation as a sine kx minus omega t, and you have minus a sine kx plus omega t. Okay, remember this. Remember this. This is important. Okay. So please note when you have sine in kx, then you have these. You have a minus sign here. And when you have cos in kx, then you don't have a minus sign here. Okay. So now you should be able to answer this. Okay, so y1 would be equal to zero point 0.2 sine of kx minus omega t, so 0.5x minus 30, and y2 would be equal to minus zero point 0.2 sine of kx plus omega t. So that is going to be your answer, guys. These are going to be your component waves. You would have superimposed these to get that standing wave equation. Okay, I hope everybody followed this. Just pay attention to the forms that we are getting. Okay. Now, once I know this, I can tell you the frequency, the amplitude, and the wave speed of the component wave. Everything is very, very easy. Once I know the equations, okay, what is the amplitude? A is this. I already told you that omega is this. So frequency I will know nu would be equal to omega over 2 pi. Okay, so that is 15 over pi hertz. Now, since you know k, you will figure out lambda also. Lambda would be 2 pi over k. Okay, so that would be 2 pi over zero point 0.5. That is 4 pi. So once you know nu and lambda, okay, you know c also. C equals nu lambda. So nu lambda would be 60 centimeter per second. Okay, the centimeter, because everything was given to you in centimeter. Okay, so you figured out everything. Now, what is left was the velocity of the particle at x equals 2.4, at t equals this. So at x equals 2.4, all you need to do is find the equation of SHM of that particle. So for that, all you need to do is put this value of x equals 2.4 over here. So you know, for the particle at x equals 2.4, y would be equal to 0.4 sine of 1.2 into cos of 30t. This is the equation of SHM for that particle. Okay, so all right. Okay. So you realize for finding the velocity, all I need to find is del v by. Okay, so that will be 0.4 into 30 to sine of 1.2 to sine of 30 into t minus. So the velocity of the particle v at 0.8 would simply be minus, so this will be 12 sine of 1.2 sine of 2.4. That'll be your answer. Okay. Again, somebody needs to give you the values of sine of 1.2 and sine of 24. Okay. If those values were known, you would have found out the speed of that particle. Okay, so this is how you go about this. So whenever any information about a particular particle is asked, then you find the SHM equation of that particle, and now you can find the velocity of that particle, you can find the acceleration of that particle once you know the SHM equation of that particle at a particular location. Okay, and you can tell everything about that particle. Okay. Now, why don't we try one more problem? So try this. Try this. So this question says that the vibrations on a string of length 60 centimeter fixed at both ends are given by the equation, which is 4 sine of pi x over 15 into cos of 96 pi t. Where x and y are in centimeters and t is in seconds. What is the maximum displacement of the particle of a point at x equals 5 centimeters? Okay. Next, what is the velocity of the particle at x equals 7.5 at t equals 0.25? Where are the nodes located on the string? And write the equation of the component waves whose superimposition gives the above wave equation, standing wave equation. So try this. Now solving this question should clarify all the doubts of how to, get all the information from this equation of the standing wave. You guys try this. Till then, I'll help myself with some water. Okay. So these are the kind of questions that can be asked of you after giving you the standing wave equation. And from this equation, you should be able to figure all those things out easily. Okay. Let's see if you can figure this out. Let's see if you followed everything that we discussed. So maximum displacement means you're being asked the amplitude of the particle at x equals 5 centimeter. What do you think is the amplitude of the particle at x equals 5 centimeter? Now, please note in this equation, for any particle, this is the equation of SHM, where this term is representing the amplitude of the particle at any x. Correct? If you write the equation of motion of a particle at a particular x, you substitute the value of certain x, then what you have is like essentially an equation of SHM, right? Okay. So, are you guys trying or should I tell you the answers? So try this. Hmm. Any answers for this one? Anyone trying this? Okay. All right. So why don't we solve this? So for the part A, let's see how you important. So you've been asked what is the maximum displacement of a point which is at x equals 5 centimeters, right? So let's try and write the SHM equation for that particle, okay? For x equals 5 centimeters, I realizes that the equation of SHM would have become y equals 4 sine of pi by 15 into 5 cos of 96 pi t. You realize the amplitude becomes this. So A at amplitude at x equals 5 centimeters is equal to 4 into sine of pi by 3. So which is 3 root, okay, 2 root 3 centimeters. So that will be the maximum displacement. Okay, that will be the maximum displacement of a particle located at x equals 5. So this is the amplitude. Okay, amplitude is refers to the maximum displacement from the mean position, correct? Now, how about the velocity of a particle at x equals 5, 7.5 at t equals 1 by 4? Okay, so let's try and write the equation of SHM for a particle at x equals 7.5. The equation of SHM becomes y equals 4 sine of pi by 15 to 7.5 to cos of 96 pi t, correct? So what we realize is the amplitude is, the equation of SHM is y equals 4 cos 96 pi t. Therefore, what will be dy by dt? dy by dt would have been equal to 4 into 96 pi sine of 96 pi with a minus sign. Okay. Now at t equals 0.25, it is dy by dt, which is the particle velocity, is minus, so this is 4 and 2 and 36, 384 minus 84 pi, I think, yeah, to sine of 1 by 4 of this, so that'll be 24 pi. Okay, so that'll be 0. Okay, so that will be 0. The particle must be at its mean at this, at its extreme at this point. Okay, you could have judged that from the position equation. Okay, at it equals 1 by 4, you have cos of 24. Cos of 24 would have referred to the positive extreme. So if it is at positive extreme, then the velocity would be 0, of course. Now, so this is done, this is done. Where are the nodes located? So for nodes, you want your for nodes, your amplitude is 0. So all you needed to find was, so you want, therefore you want pi by 15 x equals uh, 2n pi or n pi. So from here you would have gotten x would be equal to n times 15. Okay, n being the natural number, of course. Okay, so nodes would be at 0, 15, 30, 45, 60, and 75, and finally 90. Okay, so this is a 60 centimeter length, so not these. So there will be 5 nodes here. Okay. Yeah. Finally, you have to write down the equations of the component waves. The equation of the component waves, again, you have sine. in the kx. So you have sine in the kx, and this is 2a. So your component wave equations would have been y1 would have been 2 sine of kx, which is yx by 15 minus omega t, okay, and y2 would have been minus 2 sine of yx over 15 plus 96 pi t. So these would have been your component waves. Okay. So this is how you would have answered all. Okay, I hope everybody followed this. Okay. Next, we'll talk about standing waves formed on a string. So on a string, what happens is, so you must have seen this in guitars and all the musical instruments that you are playing. So what you do is you pluck the string and you have standing waves. Okay. So due to the string being bound by the two ends are forced to be notes. Okay. So the two ends are forced to be notes. Then the first mode of vibration that is possible is this. The second mode of vibration that is possible is this. The third mode of vibration that is possible is this, and so on. Okay. So we can write since in such a case, fixed ends are always going to be the nodes. Therefore, the modes of vibration possible are as shown. Okay, so these are the modes of vibrations that are possible. Okay, this is the first mode of vibration. Okay, maybe you have node here, and the entire string has just one loop. Second mode, of course, implies that you have a node here, and then you have two loops. In third mode, of course, you have a node here, you have a node here, and then you have three loops, and so on. These are the possible modes of vibrations. Okay. Now, for all these possible modes of vibration, what you can see is that your L is fixed. So, if there is one loop, if there is one loop, then or if there are n loops, so can I say that for the first mode of vibration, so let's call this first for first mode of vibration, I realize that this distance, which is L, is also equal to lambda by 2 because this is the separation between two consecutive nodes. So I will say L equals lambda by 2, which makes your lambda equals to L. Now, if the speed of the wave in the string is c, which is determined, remember, by root of t over mu. So if the tension is fixed, the mu is fixed, then your c is fixed, then the mu of first mode, which is called mu 0, would be lambda by c by lambda, or that will be c over 2l. Now this, please note, is called the fundamental frequency, also known as the first harmonic. First harmonic. Similarly, for the second mode of vibration, what you will realize is that this distance L is equal to lambda. So therefore, mu1 would be equal to C over L. Now this is called first overtone or second harmonic. Okay. Similarly, what you can say is, in general, if there are n loops, then I'll call this nth mode of vibration. Therefore, nth mode of vibration, and the frequency is called mu n minus 1, would be equal to n times e over 2l. Okay. And this would be called the n minus 1 overtone and nth harmonic. So just be familiar with the naming, okay, because the naming is very, very important. Okay, the naming is super important. You should not get confused about what a harmonic is and what an overtone is. Overtone essentially refers to the first frequency that you hear after the fundamental, and the next frequency that you hear after that, and the next frequency that you hear after that. So overtones mean the frequencies are following the fundamental frequency, and the harmonics mean the frequencies which or the multiple of the fundamental frequency that you are hearing. Okay. Now, why don't we try this question? So, in terms of T, mu, and L, you have to find the frequency of the fourth overtone mode and the third harmonic. Okay. So, for standing waves in a string, in terms of T, mu, and L, find the frequency of the fourth overtone and the third harmonic. Okay, you are a little late, guys. We discussed that question long, long time back. We are at a different question now. So try and tell me this quickly. Give me the answer to this quickly. Okay. So I just told you. If it is the fourth overtone, so remember this formula. Remember this formula whenever you're confused. Please remember this formula. This is very, very, very important. So this is called n minus 1 overtone and nth harmonic. So if you had to find the fourth overtone, so fourth overtone, n would be equal to 5, right? So frequency of fifth overtone, fourth overtone, sorry, would be equal to 5 times the fundamental frequency or C by 2L. Okay, just remember that from this. So if n minus 1 is 4, so n is 5, right? So the frequency should be 5 times C by 2L. And C I already know is root T by mu. So can I say mu for fourth overtone would be equal to 5 by 2 into root over mu. This will be your answer. Okay. Similarly, so this is part A. Similarly, for part B, you've been asked the third harmonic. Okay. Now you realize for nth harmonic, the frequency is n times C by 2L. So for third harmonic, mu for third harmonic would be simply 3 by 2L times C, which is equal to 3 by 2L times root P over mu. So those will be your answers. Okay, I hope everybody followed these. Very, very important. Please try and follow everything. How we name the harmonics and how we name the overtones. That is very, very important. We are clear about that, then trust me, the problems of this are very, very simple. So a lot of people tell me that they struggle with waves, but trust me, if you follow everything, waves questions are rather easy. Okay, and absolutely there is absolutely nothing to worry about in waves. Okay, all right. So let's try and practice another problem. A typical numerical from waves. Okay, so this tells you a massless rod BD has a length of L and is suspended by two identical massless strings AB and CD of equal lengths. A block of mass M is suspended at a point P such that BP equals X. If the fundamental frequency of AB is twice the fundamental frequency of CD, find the value of X. So that shouldn't be massless. Uniform strings, in fact, not massless. Massless strings would have infinite wave velocity, right? P by mu is zero. The massless rod AB of length L is suspended by two identical uniform strings AB and CD of equal lengths. Now the block of mass M is suspended at a point P such that BP equals X. If the fundamental frequency of AB is twice the fundamental frequency of CD, you have to find the value of X. So try this. Hmm. So try this. Let's see if you can figure this out. So what is it trying to say? If you know the lengths are equal, okay, so Tanya says L by 5. Okay. So let's try and solve this. So since the lengths were equal, and you know the fundamental frequency is C by 2L. Okay, so let's imagine that the speed here is C1 and here is C2. So what that implies is that since mu naught AB, the fundamental frequency in AB is twice the fundamental frequency in CD. What that means is C1 over 2L equals 2 times 2 over 2L. Okay, now these are equal, lengths are equal, and now C can be written as root of T1 over mu equals 2 times root of T2 over mu. What that tells me is T1 equals 4 times T2. Okay, so that is the relation that I get between the tensions in the two strings. Okay, because again the strings are identical, so the mu would be equal. Okay, so now what I can say is if I take torques about this point, and let's call this point E. So I would have had a tension of a torque due to T1 and a torque due to T2. Okay. Now taking torques about E, what I can say is taking torques about E. For rotational equilibrium, can I say T1 into X should be equal to T2 into minus X? Correct? That is very, very simple. Now I already know that T2 equals 4T2, T1 equals 4T2, 4x would be equal to L minus x, or I can say 5x equals L, or x equals L by 5. So yes, very well done. L by 5 is the correct answer. Well done, Tanya. Well done, AP. Okay. So L by 5 is the correct answer. Well done. Great, great, great. So you guys are getting a hang of this. All right, so here is another question for you. A 3-meter long string sustains a 3 loop standing wave when attached to a heavy block as shown. The wave speed is 100 meter per second. If the linear mass density of the string is 2.5 grams per meter, find the frequency of the wave, the lowest possible frequency of a standing wave in this string, and the mass of the block. So try and find this. Okay, let's see. You have told the length, you have told the number of loops. So I'm sure you can find the frequency then. What is the frequency? For n number of loops, if you remember, the frequency would be n times the fundamental frequency, correct? So this should be easy. Hmm. This should be super easy. Okay, so anybody trying? So why don't you guys try this? Until then, I'll help myself with some water. So hurry up, hurry up. This should be easy. Be easy, right? Frequency of the wave has been asked. The lowest frequency has been asked. The mass of the block has been asked. So these should be simple. Hmm. Hmm. Let's see. Let's see how many of you can figure this out. Any answers? Okay. 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 So if nobody is getting an answer, should I go ahead and solve this then? Let me know. No, I think I should. Okay. So let's see. Let's see. You have been asked the frequency of the wave Okay, so you know that there are all right. So 2.5 kg, 50 hertz. Okay. So the frequency of the wave. First, let's talk about the frequency of the wave. So you have three. Length is 3. L is 3 meters. T is 100 per second. So I know for n, so the number of loops equals 3. What is new? New is n times c over 2l. Okay. So that will be 3 into 100 over 2 into 3. So that is 50 hertz. So yes, 50 hertz is the correct answer. So well done, AP. All right. So 50 hertz is the correct answer. Now you were asked the lowest possible frequency of the standing wave. So the lowest frequency is obviously c by 2l. Okay. This again should be very simple for you to verify. The lowest frequency, is the fundamental frequency is c over 2l. So that'll be 100 over 2 into 3. That'll be 50 over 3 hertz, right? And now let's talk about part C. Part C says, what is the mass of the block? So I know C, I know this mass density. So I know that C equals root P over mu. So I know 100 equals root of over mu. Mu is 2.5 into 10 to the power minus 3. Right, so from here I get T equals 10 to the power 4 into 2.5 into 10 to the power minus 3. So tension in the string that I'm getting is 25 Newton, which should be equal to mg. So therefore, m mass of the block would be 2.5 kg, assuming g to be 10. All right. So AP, yes, two of your answers are absolutely correct. The mass is 2.5 and the frequency is 50 hertz. Okay. Well done. Well done. All right, now we will talk about vibrations in a closed organ pipe. So when I say closed organ pipe, we usually mean that one end is closed. Okay, if both the ends are closed, then you usually cannot create waves into it. Okay, so we talk about a closed organ pipe, which looks something like this. So in a closed organ pipe, you realize if you are trying to form these standing waves, then what happens is that you have to have a node here because this is a fixed end and this is an open end. So usually you have to have an antinode here because these particles, air molecules which are here, are completely free to oscillate. These particles obviously cannot oscillate. Okay. The first possible mode of vibration is this. The second possible mode of vibration is this. The third possible mode of vibration is this. So the condition is that on the closed end, you should have a node, and on the open end, you should have an antinode. Okay. So for such a such a pipe, the closed end must have a node, and the open end must have an antinode. Okay. Therefore, the possible modes of vibrations are as shown. So you can see the figure, and these are the possible modes of vibrations. Okay. So now you realize if this vibration is happening in the first mode, okay, then you realize that this is an antinode, this is a node, Okay, so the distance between these two has to be lambda by 4, which would be equal to L. So therefore, for the first mode of vibration, hence for the first mode of vibration, what I can say is that L would be equal to lambda by 4. So therefore, lambda would be equal to 4L. And therefore, the nu naught, the frequency of this mode, would be equal to C over lambda, which is equal to C over 4L. Okay, now this is called the fundamental frequency and the first harmonic. Okay, please remember that. This mode of vibration represents the fundamental frequency, and this is called the first harmonic. This is the first mode of vibration. Similarly, for the second mode of vibration, what you will have for the second mode of vibration, you will realize if you look at this figure, if you look at this figure, this entire length would be equal to lambda, correct? Okay. This is an open pipe. So this entire length would be p lambda by 4. Okay, so maybe I'll have to add a page here. Let's add a page here. I can say similarly, for the second mode of vibration, what you notice is that L equals 3 lambda by 4. Therefore, lambda equals 4L by 3. And therefore, nu equals C over 4L. Now, this note is called the first overtone and also called the third harmonic. Okay, and this is how the names go. Okay, so in general now, in general, for nth mode of vibration, we realize this nu n minus 1 becomes equal to 2n minus 1 C over 4L. Okay, this is how the frequency of any nth mode of vibration can be calculated. So first mode of vibration n equals 1, second mode of vibration n equals 2, and so on. And now this is called n minus 1th overtone and also called 2n minus 1th harmonic. So harmonic means what multiple of the fundamental frequency you are hearing. And overtone means what number of frequency after the fundamental frequency you are hearing. Okay. So please note again a important note in here. Even harmonics do not exist closed pipes. The odd harmonics exist. For a string, if you will remember, for a string, you had all sorts of harmonics. So you had the first harmonic, you had the second harmonic, you had the third harmonic, and fourth harmonic, and so on. Okay, here that is not the case. Okay, all right. So remember these terms. Now, one more point is that though we are assuming here that the antinodes are formed here. Practically speaking, the antinodes are not typically formed here, but slightly above this. Slightly above this. Okay, so there is something called the end correction E. Okay. Practically all the antinodes are actually formed slightly above the end of the rod at a distance E, which is known as the end correction. Okay, now this E has a fixed value which can be related with the diameter or the radius of the tube. Okay, so E is called the end correction. Again, important note, practically antinodes slightly above the open end. At a distance E, which is usually equal to 0.6 r, where r is the radius of the tube. Now, this is called the end correction. So, if you were to include the end correction, then instead of your here lambda by 4 would have been equal to L plus E, the true sense, if you were to include the end correction. Okay. So please note that then you would have replaced like this. So you would have gotten lambda equals L plus E. So everywhere in this equation, you would have replaced L by L plus E. Okay, if you were to consider end correction. Okay. So please remember now. So again, another note here. If you are supposed to take the end correction into consideration, note if end correction is to be taken into consideration, then L is replaced by L plus E in all the equations. Agreed? So just remember that. If you are supposed to take the end correction, then you will replace L by L plus E in all these equations. Okay. Again, take care of that. Take care of that. This is very important. All right. Let's move forward then. Next, we'll talk about vibrations in an open pipe. Now, in an open pipe, it is open at both ends. So, obviously, here you will have an antinode, here you will have an antinode. So, the possible modes of vibrations are as follows. I can say for such a pipe, both ends must have antinodes. Therefore, the possible modes of vibrations are as shown. Okay. Right. So what you have is therefore for first mode of vibration. So first, that with blue color. First mode of vibration. What you will realize is that L equals lambda by 2 and lambda equals to L. So the nu naught, the frequency would be C over 2L. Again, this would be called the first harmonic and the fundamental frequency. Now, here you will realize that all modes of vibrations are exactly similar to the ones that we studied in strings. So, all the frequencies and all the naming would go exactly identical. Okay. So, I'll leave it at that. All modes are identical to those in string. So, that's it. That's it. You can just leave it like that. Now, one thing you must realize, if you are supposed to consider end correction, now here the end correction will happen on both the ends. So if the end correction is to be considered, then you will replace L everywhere by L plus 2E. Okay, so let's make a note of that here. If the end correction is to be considered, we may choose to ignore it also. We sometimes have to consider it if the question mentions that take the end correction. Okay, or if the question mentions you the radius of the tube or the diameter of the tube, okay, then that implies you have to consider the end correction. Okay, if the end correction is to be considered, then we replace L by L plus 2E, all equations. Now, please note why 2E, because you have end corrections at both the ends. Okay, so that is what I wanted to tell you about vibrations in an open organ pipe. Okay, I hope everybody followed the discussion. All right. Now, one of the applications of these standing waves is to find the frequency of an unknown tuning fork. Okay, by using this sonometer wire experiment. Okay, so this is something very interesting. I don't know if you've carried out this experiment in your labs. At least I did as a student. I remember we did this experiment. Okay, so we have this, and then you can also find the frequency of the unknown tuning fork by water column or resonance column. Okay, so I remember doing this also in my labs as a student. Okay, so these are the applications of these standing waves essentially. Okay, so we will talk about those. And what I feel is that we don't have the time to discuss these in depth right now and go over the questions. So we will leave this discussion for tomorrow because we are running out of time for today. So this part of the discussion we will have tomorrow, and then tomorrow we will also talk about breeds. Okay. So with that, let's try and wrap up today's session. Okay. All right. Now before I take your leave for today, let me remind you quickly that if you haven't gotten your plus subscriptions and if you're planning to, then this is how you go about it. So all you need to do is go to the plus section of your app, Unacademy app, select your goal as IIT and click on the get subscription button. Now, the moment you do that, you will be redirected to the payment page where you will find a box which will say, do you have a code? Do not forget to write this code RD Live. This code will give you a 10% off on all your subscription fees, be it for the Plus subscription or the Iconic subscription. Okay, so you get this 10% off on all your subscriptions. Okay. Next, the moment you click on proceed to pay, you can also now select for a lot of no cost EMI options to choose your payments from, which makes sure that you don't feel the pinch of the payment. Okay. Now, the iconic and the plus subscriptions come at the fees which are mentioned here. For those of you who don't know what the iconic subscription is, let me tell you quickly about that. So, the iconic subscription will take your IDJ preparation to the next level by allotting you personal coaches. So those students who feel that they do better under personal guidance should go for this. So here you are allotted a personal coaches from our team of experts, and along with getting all the benefits of the plus and getting these personal coaches, you also attend extra IITJ workshops, okay, receive timely expert guidelines, get a study planner, and get regular test analysis sessions. So with these additional benefits, you can power through your IITJ journey. Similarly, for students who have just come into class 11th and are worried about their preparation for the next 2 years, can go for the combo subscriptions that are offered by the Unacademy. So, Unacademy offers you these four combos, which will take care of all your study needs for the next 2 years, be it your class 11 CBSE studies, be it your class 12 CBSE studies, and hence your boards and your mains or your IIT advanced. So all your IIT, JEE, and your school studies and your board preparations taken care by these combo subscriptions. So there are four combos which are available for students right now. The first combo offers you the iconic subscription for IIT JEE and the plus subscription for 11th and 12th. This combo starts at around 4,600 a month. The second combo offers students the iconic subscription for all three. This combo starts at 5,500 a month. Finally, you have another combo which offers you the plus subscription for IIT and the plus subscription for CBSE 11th and 12th. This combo starts at 3,000 a month. Then you have the final combo which offers you the plus subscription for IIT and the iconic subscription for CBSE 11th and 12th. And this combo starts at roughly 3,900 a month. Now, this is a list of upcoming tests in January. So you have the Unacademy Combat coming up, which is going to happen live on the 31st of Jan. Make sure you are attending this and competing there live and winning yourself some cool prizes. Then you have AIM Advance 2021 series happening every Saturday. This is very important for all the 2021 advanced aspirants. Then you have unique DPP discussions happening every Monday to Thursday. So make sure you're not missing out on any of these. Now, if you like today's video, then do not forget to press that like button and biggest of all, don't forget to share it with as many people as you can. So this is quality content being provided to you completely free of cost by Unacademy because we realize that not all students can afford these subscriptions. So we want all the students to benefit from the quality education that Unacademy can provide. That is why we have brought this channel and we are providing you quality content absolutely free of cost also. So make sure that everybody gets the opportunity to study or get this quality content. If you like the video, if you think it helped you, then make sure you share it and let the content of this video help other students as well. Now, if you're new to the channel, don't forget to subscribe to the channel to keep receiving more and more of such awesome content. And again, if you are new to the channel, do not forget to press that bell icon to keep receiving notifications of every session and lecture happening on this channel. The PDF of all the slides used in today's lecture would be available for download very soon. And with that, let's bring you to this piece of information that every student who is following us on the JEE English channel can now connect with us on the Telegram app using this link. So a lot of students give me the feedback that they have subscribed to the channel, they have pressed that bell icon, they still do not receive timely notifications of all the lectures and sessions happening here. So that's the solution for this. Okay, you can join this Telegram group and all the information of every session happening here on this channel and also other relevant channels, JEE channels will be shared with you so that you keep receiving all the relevant information. Also, do not forget to check out the links given in the description box below. Okay, so a lot of useful links have been provided in the description box below, so do check it out. They may be of help for you. Okay. Next, finally, this is where I wrap up today's session, and this is where I take your leave. But before I leave you, let me remind you one last time that this is my code RD Live. So if next time you are trying to get yourself the Unacademy subscription, do not forget to use this code. This one code turns out gives you a lot of benefits. So it unlocks the free features of the app, features of Unacademy app. Then it also gives you 10% off on both your Plus subscription and Iconic. And finally, it also helps you register for various Unacademy events like the Unacademy Combat and other competitive exams that the Unacademy is hosting for free on this uh, channel of YouTube. Okay, so make sure you remember this code and use it as whenever and wherever you want. Okay, it will give you all these benefits. And of course, with that, we'll wrap up today's session. We will carry forward with this discussion tomorrow, okay, where we will discuss about the rest of the topics of standing wave, and we'll start our discussion on beats. Okay, so I'll see you then tomorrow. Till then, you guys keep studying hard, keep practicing hard, and take good care of yourselves. Bye bye.